All right, so we've made the elements, we've meshed our geometry. Now we have to apply boundary conditions. So the boundary conditions are going to get stored in their own collectors. So if you can see under create, I have something called a load collector. Now a load collector handles loads like forces, but also constraints. They consider SPCs and those types of nodal constraints as loads. So those are all load collectors. And now actually when one goes to define a load step, let me get a little ahead of myself. I go under analysis and then load steps. Or if I go up here to setup, create load steps. You have to define, remember just like in Nastran, you specify what set ID defines all the SPCs and what set ID for all the forces that make up that particular load step. The way Altair organizes those is by keeping them on one collector. So you can think of a load collector as a set ID for holding your SPCs and a set ID for holding your loads. Okay? And that's actually probably the way you should think of it. You will need to make two load collectors, one for constraints and one for forces. Okay? Don't put them on the same load collector. It'll cause problems. Okay? So we're going to create two of them. First we'll create a load collector. We'll call it SPCs. You don't have to give it a card image. Well, I think SPC isn't even one of them. So just leave it blank, call it none, and then do create. Now you can see a little load collector. We can change the color, make it green or something. And let's create another one. Another load collector. We'll call it force. And you can give them a more interesting name like edge force if you want to. Okay? And we'll give it a color, we'll make it red, and then create. Okay? So now when I create forces or constraints, it's going to put these in these. Now, these are the same, okay, in the sense that they're both load collectors. So even though you realize that a force should go here and an SPC should go here, I have the force current. So if I start making SPCs, it's going to put them into here, okay? So be careful about that. I know the computer can't really figure out what your intent is from the name, okay? So let's make the SPCs current. We're going to go and create the SPCs. So we're going to create two SPC types. We're going to put on this edge, we're going to fix it in X and Z, and on this edge we're going to fix it in Y and Z. So the way you put in the SPCs is you go under analysis, and then there's constraints. And these are all nodal constraints. Okay? So here you can pick the nodes. This is just the size that it shows up on the screen. So sometimes it makes it a nice value. And then these are the degree of freedoms that we're going to use. So let's first put the SPCs on this edge. So on this edge, we're going to fix it in Z and in Y. So I'm going to unclick all these other ones. Okay? So that means it's just going to fix Z and Y. And then here's the value. So we keep that at 0. Okay? So if you click this, then it's actually fixing it at X as well. But we don't want that. We want it to be on rollers. So this will just create an SPC card where it's 2, 3. Okay? Now we pick the nodes. You can just pick them one by one. Or you can pick by window. A nice feature is actually you can do pick by path. I kind of like that. Allows you to pick a start one, and then an end one, and it picks all the ones in between. Okay? So now we can create those, and it creates those, draws them as little triangles. See, they're a little big, so I can make this actually 1, and that controls the size of them. Doesn't have any effect on their values, it just so it looks better on the screen. Okay, so we've created those, all right? And now if you go in, we can actually edit the cards or look at them. Click the little card thing, and I think we change this to load. Is there a load here? Load. No, wait, I gotta change this to load. This to loads here. Loads. And let's pick on one of them. So I picked that one. Hit edit. And you can see here it is. So it's that the set ID is 1. It's going on node 1655. These are the degrees of freedom. It's fixed, 2 and 3, right? And this is the value associated with it. Okay. Okay. Now let's create the ones on this edge. So we go back to return, back to analysis, constraints. Now, in this edge, we're going to fix them in Z and X. So let's check the X degree of freedom and uncheck the Y degree of freedom. Let's pick the nodes. Pick them by path again. There's the first node, and we're going to go all the way up to here. And let's get that top one. There they all are. Create. There's still in this load collector, even though they have different values. You can see here, if you zoom in on it a little bit, we do a control and then middle mouse button, and we can draw a little zoom window, and you can see they're all set to 1, 3, right? 1, 3. If I turn off I can toggle the view on and off, but just to check that they're all in there, okay? When they're green, that denotes that they're all in that layer as well. All right. Now the next thing we need to do is put the force on top. All right. So you can actually do P-load 1 cards in here, I think. Let me just check. Do they have those? No. Okay. Let's see. I'm just seeing which ones lets me do a P-load card. Okay. So you can do the P-load options here, all right? But they're a little tricky. We haven't talked about them too much. I'm actually just going to put the forces up here manually, okay? I'm going to just put them by hand. Whoops. And I'm going to do that by, let's just, all these elements have the same size, so it makes my life a little easier. Let's figure out how long an edge is. So if we go to geometry and we pick distance, pick 2 points. You can see the distance between those 2 points is 0.39 inches, right? 0.39 length units. Okay, so, or in other words, I guess I could do it. The force at each node, well, we know the distributed force. Well, let me show you the picture, it's probably easier. Let's go back. Okay. All right. So I know this distributed force has a value of 10,000 kilopounds per inch, right? Each element has a size of 0.3, what did I say it was? 39 inches. So that means each element has a force on its edge. The total force acting on its edge of 10,000 times 0.39. And that is equal to, well, I should be able to figure it out. It should be, right? It's 3,900 pounds. Okay? Oh, you can't see any of that. I'm sorry. Sorry about that. I drew the element. This is one element. It has a length of 0.39. The total force down on one element's edge is 10,000 pounds per inch times 0.39 inches. So that means this force is actually 3,900 pounds. Okay? All right. So that puts basically at each node half of that. So it would put it. So this element would contribute onto this one and this one half of the 39, which is 1950. But on nodes that have an element on both sides, it's going to get 1950 from both sides. So on these, you're going to get a contribution here of 3,900. So basically what's going to happen is, on the edge nodes, here, yeah, you can't see it because I zoomed in. on these edge nodes, since they only have one element, let me draw it better. On this node here, because it only has contribution from one element, it's going to get an upward force of the 1950. On the ones on the interior, where you get contributions from two elements, they're all going to have 3900, and on this edge, it'll be 1950. Okay? And that's the way it works to get a distributed load. If you set them all to 1390, actually you have a little extra force, and you'll see you'll get a little stress concentration at the corners, and that's technically incorrect. Okay? We talked about distributed loads in class as well, but that's the way it goes. Okay? So we can do that now. All right. So to create the force, what are we doing? Come on. Turn. What's going on here? It's like hung up. Why doesn't it return back to the main screen? Something's going on here. Okay, let's just get it. Okay, I got it out of the there. Why doesn't it go back to the main screen? Huh. Geometry. It's not going back to my main screen. Something that's like hung up. All right, well, let's just, I think we can just go with it. You should be able to get to the main screen by hitting return or something. And I seem to be stuck. What if I just do one of these? Let's just let it do this. Does that help it any? No, it's still stuck. All right. Let me save it. Well, it's not. Oh, there it goes. Now it goes back. Okay, fine. So to create a force, it's under analysis, just like constraints. And then we're going to pick forces. Now, when you do a force, you pick the node. You also have to pick the magnitude. That's the number value, so it's going to be like 3900. And then the direction. Okay? So our forces are all going to go in the y direction. Let's pick the middle ones. These are going to have values of 3900. This one just scales the size, just like the size on the MPCs. And let's pick these nodes. I should do it by path. So I have all those. Create. All right. And there they are. Oops, they're really big. Let's scale them by 1. And they're still pretty big. 0.1. Now it's look. All right, that looks good. They're all in there. The only problem I have now is I forgot to change the active load collector to edge force, so it created them in SPC. So we need to, well, you could delete them and then recreate them, but I'll actually show you how you move things around. So let's zoom in here, do Control middle mouse button, so to zoom in. And then when you have to move things around, it's actually under Organize, and it's under Tools. So if you go under Tools and Organize, this is a pretty useful feature. This allows you to move things around from collector to collector. So we're going to move the loads from the SPC collector to the edge force collector. Okay? So let's change this, because we don't want to pick elements, we want to pick loads. So now I can go and select the nodes, and you have to actually pick their little tips of the arrows. Pick them all. So those are the ones we're going to move. And then we're going to select the destination component to be edge force. Probably already selected it since we made it current, but okay. And now we're going to move. We don't want to copy, we're going to move. Now you can see they all turned red, they're happy. Okay? So that means they're on that level, right? Okay, toggle them on and off. Now I just need to put the half force on these edge nodes, right? That's the 1950. So let's go back and add those. Let's go back to return. We'll do analysis. And then forces. And these are going to have a value of 1950. They're still going to act in the y direction. So let's pick the edge nodes. We're going to put one here and one here and create. And there they are. You can see the half forces. So that's good. We've defined our loads and SPCs. And if you had multiple ones, you could, if you wanted other SPCs for another load case, you'd have to make another load collector for like SPC2 or some other condition like that, and then create those, okay? All right. All right. Well, why don't we stop there, and then the next step we'll finalize our model. Oops, that's not what I want to look at. Where is it? The next step, we'll finalize our model. Okay, we've done this step, we've made the geometries, we've meshed, now we've defined the forces and the SPCs, the boundary conditions. Last thing we've got to do is define the load cases and export the Nastran file, okay? So we'll do that next.